Hello guys, welcome back to Maison African Motives, still on our revisions, working on our mathematics for grade 10. This is still on our algebraic expressions, but in this case, we shall be focusing on the factorization of our algebraic expressions. So if you are to consider exactly what is it that we are talking about on the factorization, remember on the previous case, we had the expansion of brackets whereby you are multiplying algebraic expressions. Take an example, you've got x multiplying x plus 3 like that. This was an expansion that is the one that you are having here. You are expanding brackets. So in that case, you are expanding the given brackets, whereby you are going to multiply this by x, multiply everything by x in the other bracket. You're going to have x times x, which is x squared. Remember, I said x and x together. This is 1. This is 1. So we're going to add 1 plus 1, which is 2, plus x times 3, which is going to give us 3x. All right. Now, factorization is a reverse of everything that we had. That is the part of the factorization part. Factorization is putting back the brackets to have this part of the brackets that we have here from this part going back. So it's a reverse of the expansion or expanding or multiplying that we had of the brackets. We expanded the brackets. Now we have this expression, which is supposed to be written in terms of the brackets like that. So how is this possible? All right, whenever you are to consider the factorization, let us say we are dealing with a binomial. Remember, a binomial, we've got two terms, all right? So let's say we are dealing with a binomial, all right? A binomial in this case, whereby we have got two terms to consider. In that case, what we are going to see is that, for an example, we have got x squared plus 3x. What you just need in this case is what you refer to as the highest common factor, which is the HCF. The highest common factor, that is the term that is common between these two terms, and it must be the highest term. So on a condition like this, we can see that here we've got x, which is x squared, and here we've got x, which is to the exponent of 1. If you are comparing between such terms being raised to a certain exponent, one, the thing is that the term has to be common. That is the first thing. The term has to be common. We've got x, yes, we've got x here, it is common. Then you take the one that has got the smallest exponent or the smallest power. So we're going to take the one with the smallest exponent. That is one that you refer to as your highest common factor, which is reversed by the LCD or the LCM, which you take the one that has got the highest power. So you take the one that has got the highest power for the LCM. We shall talk about that when you're dealing with fractions. But in this case, you are dealing with the HCF. So you take the one that has got the smallest exponent. And in this case, we are referring to x to the exponent of 1, which is x. So we are going to factor out x, all right? That is for a binomial expansion expression. You just have to factor out a common term. Then that term that you have factored out of the bracket, now you have to divide back. So we're going to divide x squared divided to x. So we are simply having something like this, x squared over x. All right, so you can see that there are two of them. So if I divide here, I'm going to be left with 1x on top, or you are simply saying this is x to the exponent of 2 over x to the exponent of 1. I'm dividing the same basis, so I'm going to subtract the exponents. So that is going to be x to the exponent of 2 minus 1, which is 1. So that's x to the exponent of 1, which is x. All right. So it is the same thing that you are going to do on this part of 3x. All right. We are going to have the same thing on this 3x, and the part that you have factored out, you are going to divide again. So that means we have got 3x divided to x like that. So the x and the x are the same. they will cancel each other. You remain with 3 over 1, which is same as what? Which is same as 3. So that means here we are going to have a plus 3. So if we are to check our final answer, which is the fact after factorizing, we have a bracket. We have the same answer as this part that we had before, which is x into x plus 3. So like I said, the expansion of brackets or expanding of brackets and factorization is a reverse of each other. Expanding brackets, you are removing the brackets. Factorization, you are putting in the brackets. You are going to have your answer in terms of the brackets. So all that you just need is to find the highest common factor of the given terms if you are working with a binomial, or if you are working, you can even work with a trinomial expression, but having common terms. You have to do that. That is the golden rule to factor out the highest common factor. We shall see different types of factorization. Just make sure that you watch each and every video that we're going to have on the factorization so that you understand how to deal with these questions. So we are given the questions on this part, on this exercise, factorize. All right, so let us see the first part of our question. We are asked to factorize, in this case, that's 6x to the exponent of 3. So we've got 6x to the exponent of 3 plus 12x. All right, so let us consider in this case, there are two terms, that is, we are dealing with a binomial expression. So you can factor the highest common factor, starting with the numbers. We've got 6 and 12. So the highest number that we have between 6 and 12 is going to be 6, all right? So you can consider, guys, the highest common factor, a factor, the number that is common that we can divide through and we do not have a remainder, is going to be 6. 6 over 6, that is a 1. 12 over 6, that is a 2. We cannot use 12 because if we divide 6 divided by a 12, you do not have an exact term. You are going to be left with a fraction. So it cannot be the highest common factor, but it can be the LCM. All right. So that means the HCF is going to be 6 in terms of the numbers. Then you consider the terms. This is x to the exponent of 3. This is x. Remember what I said. If you have got this condition, you consider the one that has got the smallest exponent, and the one that has got the smallest exponent, it's x. So that is our highest common factor, will be 6x. So if I factor out 6x, what does it mean? It means I'm going to divide the first term to a 6x. All right, so let us divide and see 6x to the exponent of 3 divided by 6x. So as you can see, 6 and 6 will cancel. Then on this case, we are dividing the same basis. So we're going to subtract our exponents. That's 3 minus 1, which is going to give us 2 in this case. So that means we are going to be left with x to the exponent of 2. Remember, 6 and 6 cancelled. All right, then we move on to 12x. We are going to divide these two 6x. So if we divide 12x and 6x like this, 6 into 12 is going to be 2, or 12 divided by 6, that's 2. X and x is go cancel. These are the same. If you want, it is going to be x to the exponent of 1 minus 1, which is x to the exponent of 0, which is 1. Then 1 times 2, which is going to give us a 2. So that will be a plus 2 in this case, right? So as you can see, that is how we could have factorized this part. And also, after factorization, this part inside the bracket, we must not have a common term. If you have anything common, let's say after factorization, you obtain your answer as 2x plus 4 like this, it means you are not yet done to factorize, because you cannot have a common factor also between these two terms after you have factorized. So that's why you are supposed to factor out the highest common factor. It's not about just having the brackets, no. It's about having a bracket in simplest form without a common term in this bracket, right? So let us consider question number 2 in this case, where we have got a 6x to the exponent of 3 plus 4x squared. All right, so if we have to consider the highest common factor, let us start with the numbers 6 and 2. The highest number that we have is 2 in this case. Or if you have a confusion on these numbers, you can just consider your numbers as product of their prime factors. You consider 6 as a product of its prime factor, you start by the smallest number, which is 2. 2 into 6, that is 3. You divide, yet 2 cannot be used. We can now use 3. 3 into 3, that is 1. Right? You do the same thing for 4. 4 is the same as 2 into 4, that is 2. 2 into 2, that is a 1. So the highest common factor is a continuous where it is common. So as you can see, 2 is common, but 3 is not common, and also this 2 is not common because we've taken this 2 and this 2, which is common. So we are going to see that the highest common factor is going to be 2 between 6 and what? And 4. So we are going to take 2. All right. Then we move on to x. That's x to the exponent of 3. And this is x to the exponent of 2. So what are you going to do? You're going to take, remember I said the one that has got the smallest exponent, it becomes your HCF. So you're going to take the one with the smallest exponent. So that is our highest common factor that we factor out. Then we can divide after that, right? So that means here we're just going to divide 6x to the exponent of 3 divide by 2x squared. All right, so that's 6x to the exponent of 3 divided by 2x squared like this. This will cancel. 6 divided by 3 by 2, that is 3. And here you are dividing the same basis. You're going to subtract 3 minus 2, which is 1. So that will be x to the exponent of 1, which is just 3x. All right, you do the same thing on 4x squared. It's a positive over 2x squared. So 2 into 4, that is going to be 2. X squared and x squared are the same, so they will cancel each other. You remain with a 1. So 2 times 1 is going to give us a 2. So that is what you are going to have at the end. So as you can see, all of these factorizations that we have, if we have got 2 terms, it's just a direct factorization. All you just need is to have the highest common factor, and you can factor out that highest common factor. So I want you to try as much questions as you can. So if you have to check this one, number 3, I think is direct again. That's 5x to the exponent of 3 plus 5x. All right. So if you have to check, there's 5, there's 5. So you can just factor out 5, which is the common factor. Then x cubed and x. Remember, I said we take the one with the smallest exponent, which is x. So that means 5x is going to be our highest common factor. Then we divide 5x cubed divide by 5x, which means we are going to obtain 5 and 5 will cancel. X cubed divided by x, that means we are going to subtract 3 minus 1, which is 2. So that will be x squared. Then we divide 5x and 5x. But as you can see, these terms are the same. So they will cancel each other. 5 and 5 will cancel each other. X and x will cancel each other. That means we've got 1 over 1, which is a 1. So this is going to be like that, right? So that means if you understand this, guys, you'll be able to factorize whatever type of an expression that you are given, all right? Whether you are given the question like number 4, where we have got 12x to the exponent of 3 minus 18x squared, all right? So like I said, you can consider determining the highest common factor of the two numbers, which is 6 in this case. But if you cannot determine that direct, write your number as a product of its prime factors. 12, the smallest number that we can use is 2. So 12 divided by 2, that is 6. Can use 2 again. 6 divided by 2, that is 3. Then we can use 3. 3 divided by 3, that is a 1. All right, you do the same thing on 18. All right, so you're going to consider 2 into 18. That's 18 divided by 2, which is 9. All right, you consider 3 this time. 9 divided by 3, which is 3. Then we can consider 3 again. 3 divided by 3, which is 1. So the highest common factor has to be common. Like this 2 here is common. And we also have a 3 and a 3. So that means the highest common factor, we are going to consider 2, which is common, and also 3, which is common. So 2 times 3, that is a 6, right? Or you can just, you have to know it, but by your multiplication to say what is the biggest number that I can factor out between 12 and 6. If you know it, then you can just write it. Or if you do not know, then consider this part. It can be so helpful. All right. So the highest common factor there is going to be a 6. Then we consider between x and the other x. So that's to the exponent of 3 to the exponent of 2. We take the one with the smallest exponent, that is x squared. So that becomes our highest common factor. So the rest is just dividing back. All right, so you're going to divide back this term to the highest common factor, that is 12x to the exponent of 3 divided by 6x squared. So we divide 12 divided by 6, that is 2. This is x to the exponent of 3 divided by x squared. You're going to subtract your exponents, 3 minus 2, which is 1. So that will be positive 2x. All right, you do the same thing here. I've got negative 18 x to the exponent of 2 divided by 6x to the exponent of 2. So 6 into negative 18, that will be negative 3. All right, then x squared and x squared are the same. They will cancel. So it will be negative 3 times 1, which is negative 3. So this becomes our answer in a simplified manner. So as we can see, guys, we can be able to answer whatever question that we are given in your revisions. All right, considering question number 5, it is a trinomial. We've got 1, 2, 3 terms in this case. All right, but what is the idea of this question? Are we going to consider the same situation or the same scenario, just like the previous question that we had? In this case, we've got this as plus 12 xy like this. Okay, so this term that we are seeing in this case is a quadratic. We are dealing with a quadratic trinomial. All right, so we have got 1, 2, 3 terms. All right, so we are supposed to ask yourself, if you are to factor out any common term, do I have a common term between these? All right, if you consider x, here I do not have x. All right, if you are to consider the part of y, I have got y here, I've got y here, but I do not have y. So y cannot be a common term. All right, let's consider the numbers. I've got 3, I've got 9, I've got 12. So there 3 can be given as the highest common factor. So I can factor out 3 in this case. If I factor out 3, it means I have to divide 3, divide by 3, which is 1. So that is going to give us x squared. All right, you do the same thing. You divide minus 9, y divide by 3. So that's negative 9 divided by 3, which is negative 3y in this case, plus 12 divided by 3, which is 4. So that is going to be 4xy like that. All right, so if I'm to consider here, I do not have a condition whereby I've got common terms that I can factor out. Yes, between these two terms, y is common. So I cannot factorize further. And this type of a quadratic expression cannot be factorized further, whereby we can have 2 brackets at the end. But maybe what you can just do is that here, because y is common, you might think to say, okay, let me write as x squared minus, I factor out y like this, negative y. This will be positive 3, and this will be minus 4x like that. All right, you're having a 3 outside. So as you can see, it's a factorization and another bracket in the, which is one and the same thing. So here you can just leave it like that, or if you want to write in an extended format, you can have in an extended format like that. We do not have a condition whereby we can have 2 brackets that we can use, but we've got a condition of having this x squared as part of our factorization, where we end up having 2 brackets. So do not confuse with this question that we see here. All right, so that is the same scenario that we are having on question number 6. I want you to try this. All right, let us just see question number 7 in this case. So I want you to try the question number 6 and see if we are together. But with me and you are going to try together the question 7, where we are given 16 m to the exponent of 4, n to the exponent of 8, minus 8 m to the exponent of 3, n to the exponent of 7, plus 36 m to the exponent of 2, n to the exponent of 3 like that. All right, so that is what we have on question number 7. So like I said, I want you to try this question number 6 and see if we are together. All right, so if you're to consider the question number 7 that we have, we've got terms the numbers 16, 8, and 36. So you have to consider the highest common factor between these two numbers, which is supposed to be something like 4 there, all right? But we can just try. Remember, I said you can just write your numbers as product of them, their prime factors, 2 into 16, that is 8. 8, we can use 2 again, 8 divided by 2, which is 4. Then again, we can use 2 here, 4 divided by 2, which is 2. Then we can use 2, 2 divided by 2, that is a 1. All right, we can consider 8, but as you can see, 8, we have already calculated the part of 8 there. So it's just a repetition that is happening on 8. We've got 8, we say 2, which is going to give us 4. 4 by 2, 4 divided by 2, that is 2. Then again, we can use 2, 2 divided by 2, that is a 1. All right, then we can do the same thing on this 36 here. So 2 into 36, that is 36 divided by 2. That is going to give us 18 in this case. Again, we can divide by 2. 18 divided by 2, which is 9. Then 2 cannot be used. We move on to 3. So that is 3. 9 divided by 3, which is 3. All right, then we can use 3 again. 3 divided by 3, which is a 1. So considering the highest common factor, we can consider 2 is common here. 2 is common on these numbers. We've got 2 being common. Also, we've got 2 being common here. Got another part of 2. All right, this one is no longer common. We've got 2 here. We've got 2, but we do not have 2 on this side. We've got 2 here. We no longer. We've got 3 here. We do not have. So these ones cannot be taken as part of our highest common factor. It must be a common term to be considered. So as we said, the first part that was common is the 2. And also the 2 is, this one is still common. So it's going to be 2 times 2, which is 4. All right, like I said here, we are going to have this as 4. So between the numbers 4, 8, and 16, we are going to factor out 4. Then we consider our terms. For the terms, like I said, you just have to consider, is the term common? That is the first thing. We've got m, we've got m, we've got m. Once we have that term being common, you take the one that has got the smallest exponent, and that is m squared, the one with the smallest exponent, which is m to the exponent of 2. You do the same thing on this n. You consider that we've got n throughout, but which one has got the smallest exponent on n? That is n to the exponent of 3. So you take the one with the smallest exponent. So this is your highest common factor. All right. So you just have to take the one that has got the smallest exponent, or the smallest power in this case. All right. So now we are going to divide, just like I indicated before, that once we have this highest common factor, we are supposed to divide back this term to the highest common factor, also this term to the highest common factor, this term to the highest common factor, like that. All right, so let us divide 16m to the exponent of 4 and the exponent of 8 over, this is 4m squared n cubed. All right, so that's 16 divided by 4, which is going to be a 4, right? Here we are dividing the bases that are the same. So we are going to subtract our exponents. That's 4 minus 2, which is going to be 2. So we're going to have m squared. All right, we consider the same thing on this n here. This is 8, this is 3. So we're going to subtract 8 minus 3, which is what? Which is 5, because the bases are the same. So we are going to have at the end 4m squared n to the exponent of 5. So with the same situation or the same part, we're going to consider this on this term. That is minus 8 m to the exponent of 3 n to the exponent of 7 over 4m squared n cubed, like that. So you're going to divide negative 8 divided by 4, which is negative 2. So if we divide 8 by 4, that is 2, but we've got a negative, so it will be negative 2. The bases here are the same on m, so we're going to consider the part of m here. The bases are the same, we are dividing, so we subtract our exponents 3 minus 2, which is going to give us 1. So that is m to the exponent of 1, which is same as m. All right, we consider n here, the bases are the same. We subtract our exponents. So that is going to be 7 minus 3, which is 4 in this case. All right, so this is what we are going to get, negative 2m. All right, so you're going to have negative 2m n to the exponent of 4. So this is n, all right, n to the exponent of 4, all right? You do the same thing on the last part. You are considering 36m squared n to the exponent of 3. So that is 36m squared n to the exponent of 3 divided to the first term, that is to the common term, which is 4m squared n cubed. So 36 divided by this 4 is going to give us a 9 in this case, all right? So if we divide properly 36 and 4, that is going to give us a 9. But as you can see, this term and this term are the same and having the same exponent. So we can simply cancel them, right? This one and this one are the same, so they cancel each other. So that means I'm just going to be left with a 9. So this is going to be plus 9 like that, all right? So as we can see, after our factorization, we do not have any common term between the bracket here. If we check from the first part up to the last term, we do not have any common term. Do not consider to say that I have got m, I've got m. We have to consider throughout. We do not have m here, so it's not a common term. We have got n here, we've got n here, yes, but here we do not have n. So it's not a common term. So that means this answer is in a simplest form. Also, if you check your numbers between 4, 2, and 8, and this 9 that we have, we do not have a common term between these numbers. The only common term that is there is a 1. So it means your answer is in the simplest form when it's like that. Do not say you have factorized whilst you still have common terms inside the bracket. It means you have to factorize again or refactorize your expressions again. All right, then we've got the B part here. I'm just going to pick 1 or 2 questions because it's just a continuation of the last part that we had. Only that if you have to check, it's just an extended factorization that we are having. Let us consider the first question. We are given x into the bracket of a plus b plus y into the bracket of a plus b. So it's just an extended factorization that we are seeing. One and the same thing like what we had, only that the common term now is a bracket. So if you have to check there, we've got a plus b, we've got a plus b, which is common. So you are going to factor out that common term, which is a plus b, like this in a bracket. So if you factor out a plus b, what does it mean? You are going to be left out. Remember the concept, you're supposed to divide. So it is going to be x into a plus b divided by the highest common factor that is outside, which is the bracket of a plus b. So this will cancel. You remain with what? With x. So as you can see, if the bracket and the bracket are the same, you just cancel this, you cancel this, you remain with x. But you do not cancel this, but actually you just imagine like you are canceling. What is going to remain? We are going to remain with what? We are going to remain with x. So it is the same thing, plus a plus b, and a plus b is common. So if we divide this bracket and this bracket, we are going to be left with what? Plus y in this case. So that means at the end, we are going to have this as our final answer, and we do not have any common term that we can consider in this case. All right, so that is how we can simplify such type of questions. You just have to consider, do I have a common term into the bracket? Like this part here, we have got a common part, x plus y, x plus y. So you factor out that x plus y. So what do you remain with here? You remain with k. What about here? You remain with plus p. You are done. There's nothing that we can do. But now what do they try to do is that they just try to confuse us with exchanging of the signs inside of the brackets or the layout of the terms inside the bracket. All right. Let me just consider this question before I talk about that part. Number 6. So I want you to try the other questions. But if you've got a question that is challenging, let me know so that we can work it out together. For number 6, it is the same situation. Do not be confused because of these exponents. It is the same idea or the same situation that you're going to have. This is a plus c to the exponent of 4 plus a plus c to the exponent of 5 like this. So as we can see, these two brackets are the same. We've got two brackets that we have. The bracket of a plus c, the bracket of a plus c raised to the exponent of 4, this one raised to the exponent of 5. They are the same brackets. So we just have to consider that as a common term. So the highest common factor is going to be the bracket of a plus c. But we take the one, because it is common, we have to take the one that has got the smallest exponent, because there is another one with the biggest exponent. Remember what I said about the highest common factor. If it is common and raised to different exponents, you take the one with the smallest exponent. So that means in this case, we are going to have a plus c to the exponent of 4. We divide because we have factored out this as the highest common factor between these two. So the actual sense was you are supposed to divide this bracket to this. So it's a plus c to the exponent of 4 over a plus c to the exponent of 4. So these two terms are the same. They just cancel each other. There's nothing that you're going to do. So it's just going to be a 1 plus you do the same thing on the bracket of a plus c to the exponent of 5, meaning to say we are supposed to have a plus c to the exponent of 5 divided to the bracket of a plus c to the exponent of 4. So going back to our exponents, when we are given the part of the same basis, a plus c is the same as a plus c. I'm simply going to subtract the exponents, which is a plus c to the exponent of 5 minus 4, which is a 1. And remember that a plus c to the exponent of 1 is same as a plus c. Any number to the exponent of 1 remains as it is. So a plus c, when raised to the exponent of 1, it is just going to remain as it is, as a plus c. So if I factor out a plus c to the exponent of 4 from this term of a plus c to the exponent of 5, I'm going to be left out with what? With a plus c. Yes, I can open a bracket, which is fine, or I can just leave my answer like this. So that is our answer in simplest form. There's nothing common to be considered there. All right, so like I said, some of the questions, they might just try to confuse us where you find them interchanging the signs, this and that. So I just want us to check one or two questions of that nature. If we consider what we have on question, all right, this is question number 9. Let us consider question number 9. We are given on question number 9, 7x into the bracket of m minus 3n like this, plus 4y into the bracket of 3n minus m like this. All right, so this one is a confusion that we are having here. These two brackets are not the same. This is m minus 3y. This is 3n minus m. So we've got m minus 3n, sorry, and here we've got 3n minus m. m minus 3n, 3n minus, they are not the same. All right, do not confuse here, guys. Minus 3 plus 2 and 2 minus 3, these two are the same. Why? We have the same sign, the negative 3, here it's a negative 3. It was a positive 2, here it's a positive 2 again. But if you consider what happened here, these two are no longer the same because here it's a positive m, here it's a negative m. All right? If you consider n, this is negative 3n, this is positive, they are not the same. If it was given as negative 3n like this, plus m like this, these two, they are the same because m, it's a positive, m here, it's a positive. 3n, it's a negative, here it's also a negative. These ones, they are the same, but these two here, they are not the same because n it's now a positive, but here it was a negative. So what do I do to make such type of expressions to be the same? All right, it follows that if I am given a into a minus b like this, I want to interchange this. If I factor out a negative from this bracket here, if I factor out a negative, it becomes minus a plus b, which simply means I've got minus into b minus a, which is the one and the same thing. So if I factor out a negative, it can change the order of what I have in this bracket and also the sign inside the bracket. So I'm going to consider that condition, but considering it from the second bracket. So I'm going to leave the first bracket as it is, that is 7x into m minus 3n. On the second bracket now, that's where I have to factor out the negative. Remember I said if I factor out a negative, so this already it's a plus, and we factor out a negative, so it will be a plus, all right? It's going to be a plus and a minus, which is going to be a negative at the end. So that means we're going to have minus 4y in this case. But what we have done is that we have factored a negative from this bracket. So if we factor out a negative, it means we are going to divide by a negative, all right? So it's going to be positive, this one, divided to negative, which is going to be a negative 3n. We are not factoring, 4y is already out of the bracket. Do not consider to say we are dividing 3n and 4. No, we are considering the sign that we factored out, this one. So it's going to be minus m divided to minus, which is going to be a plus m. So as we can see, these two brackets, they are now the same. This is positive m, this is positive m. This is negative 3n, this is negative 3n. They are the same. So that means I can rewrite in a way that I understand. That is 7x into the bracket of m minus 3n. All right, this one, it has changed because we wanted to make these two brackets to be the same. So the sign here, it has changed. So it's now minus 4y into, I now rewrite starting with the m, all right, because this m is the same as this m and it's a positive now. So it's going to be m followed by minus 3n because we are now having this as the same as this bracket. As we can see, they are the same now. So that means at this stage, I can be able to factor out what is common, which is the bracket of m minus 3n. This bracket and this bracket of m minus 3n are the same. So you factor out the common bracket m minus 3n. What do you remain with if you cancel? If you factor out, you're going to cancel this bracket and this bracket. You remain with 7x. This bracket and this bracket are the same. They will cancel each other. I remain with minus 4y like this. All right, so this is what you were supposed to have at the end, having two brackets. So guys, you have to be very, very careful. Do not just answer question rushing because you have seen a question that you are familiar to. Understand how the numbers are given. So like I said, I'm not going to answer every question. Let us just see question number 11, then you try other questions. On question number 11, we are given 2x into 3p plus q in this case, plus 4y into minus q minus 3p like this. All right. So if you are to consider again, we are asked to factorize here. These two terms are not the same. This is 3p plus q. This is minus q plus minus. So here there's a negative and negative. All we just need is to make sure that these two terms are the same. But here's an advantage because the negative is common. And if we factor out a negative, it becomes a positive, just like the first part. So here we are going to factor out first on this bracket so that it will be the same as this bracket. What is just affecting is the minus that we are seeing here. So we are going to factor out the minus. If we factor out the minus, it affects the sign here. So it's going to be minus 4y, all right? It was a plus, then because of the minus that we factored out, it will be plus and a minus, which gives us a minus. So the moment I factor out the negative, it means negative divided to the negative, it becomes a positive. Negative divided to the negative, it also becomes a positive. So as we can see, this bracket and this bracket are the same. I can just rewrite in a way that I properly understand, but as we can see that these two brackets are the same, but I can just rewrite this second bracket starting with 3p, just like this part. So we are going to start 3p, and as you can see, it's positive, and here it's also positive, so it does not affect anything. All right, q here is positive, and q here is now positive, so it's going to be plus q like this. Once you have this, you can factor out what is common, and what is common now is 3p plus q, 3p plus q. So we're going to factor out the bracket of 3p plus q in this case. If I factor out this bracket here, it means I'm going to remain with 2x. So I'm going to take that 2x, all right? The same thing here, if I am to factor out this bracket, divide with this, I'm going to be left out with minus 4y like this. All right, so if we are to consider this question that we are seeing, yes, we are factorized, but it's not fully factorized. We are supposed to fully factorize. That means your factorization must be in its simplest form. So if we are to check on our final answer, it's not in simplest form because of the second bracket that we are seeing here. 2 is common here between 2 and 4. So we are supposed to factor out that 2 which is common. So it's supposed to be 2x minus 4y like this. 2 is common. We can factor out 2. We remain with 2x divided to 2, which is going to give us x minus 4y here divided to 2, which is going to be negative 2, but we are going to take the y that is remaining there. So that means this part that we are seeing here can be written as 2. So it was going to be 3p plus q like this into 2 into the bracket of x minus 2y like this. So this number 2 can multiply the outer because this is just same like there's a 1 there. So just multiply 2 times 1, which is 2. So the 2 is going to be at the end. Yes, you can write with its bracket, or you can just write the 2 as it is, and these brackets as they are, 3p plus q into the bracket of x minus 3y like that. Or like I said, you can take these two along with this bracket on this part, then you end up with the bracket of 3p plus q at the end. That one, it's your choice, guys. But as you can see, now our answer is in simplest form. We do not have anything common in the brackets. That is to fully factorize. To fully factorize, it means you are not going to have anything remaining common in the brackets. All right, so those are the typical questions that I want you to try and work on. So you can try question 12, question 14, a lot of questions, but here let us just try to have our question 15 as our last question. So question 15, we are given a minus 3b, in this case minus c, into the bracket of 3b minus a plus d into the bracket of 3b minus a. So as we can see, we have got a same condition that is similar but not the same. This is a minus 3b, but now we have 3b minus a. They are not the same. 3b is being a negative here, but here it's a positive, same as here's a positive. So they are not the same. Here it's positive a, but on this bracket, this is negative a, this is negative a. So what do you do to make sure that these brackets are the same? Considering the first bracket as it is as a minus 3b, I'm going to change the other brackets. That means to be the same as a minus b, a minus 3b. So what do? I simply factor out a negative from those brackets. Here I factor out a negative. So that means I'm now having a negative with a negative here. So negative, negative, it will be a positive C. Take note, guys. Negative, negative, I factored out a negative and it's now a positive. But the negative that I factored out is the one that I'm using here. So it's 3b divided by this negative, which gives us negative 3b, all right? Negative a divided to this negative, which is a positive a. So be careful on that part, all right? So as you can see, the two brackets will be the same because a is a positive, a is a positive, b, 3b is a negative, 3b is a negative. So they are the same. So you factor out the negative, but that negative that you factor out here, you have to multiply to that term by the negative. Then the term that you factored out, you have to divide by it. So it's 3b divided to the minus that you factored out, minus a divided to the minus that you factored out, which is the same thing. Here we're going to have a plus and a minus, which is going to give us negative d. Then we divide. So it's the negative that we factored out. So it's only here that it's a plus and a minus. So when I was saying 3b divide by this, it was like we are dividing by this sign. It's only that because it's a plus and a minus, but the sign that you're dividing with is this sign that you factored out. So it's 3b divided to the minus that you factored out, which is minus 3b, all right? Minus a divided to the sign that you factored out, which is going to be a plus a. So you factored out this minus, it affects this sign, all right? And when you factor out, you have to divide by that term that you factored out throughout. So as we can see, like I explained, this is positive a, this is positive a, minus 3b, minus 3b, minus 3b. So these three brackets are the same. So I'm just going to write in the way that I understand. So I'm going to have this as a minus 3b plus c into, I start with a positive a. So it's a minus 3b. The same thing, I start with a positive there. So it's going to be minus d into a minus 3b. It's one and the same thing. I'm just rewriting in a way that I understand in the same way so that I can properly see that I am factoring out what is common, which is a minus 3b, a minus 3b, a minus 3b. So I'm going to factor out that as my highest common factor of a minus 3b. So if I factor out this bracket, what am I going to remain with? Remember what I said? You have to cancel because they are the same, a minus 3b, a minus 3b. So you're going to remain here. It's the same as there is a 1 there. If you're just given a term, so if you cancel out, there is a 1 that is going to remain. So that's a 1, all right? A minus 3b and a minus 3b, they cancel each other. So meaning to say, we are going to remain here with a plus c. So it's going to be plus c. A minus 3b, a minus 3b, they're the same. They cancel each other. That means here we are going to be left with minus d. So at the end, this is going to be our answer. As we can see, we do not have anything common between these two brackets that we can factor out later on. So your factorization, it's all about the highest common factor, the term that is common from the given brackets. You are supposed to work with the common term. But if the signs, they try by all means to give you equations with different layout, check on the signs there. So if the moment you factor out a negative, the bracket that you have will be the same as your reference or the bracket that you are using on the first place. So you just have to factor out what? A negative. Remember, a negative, when being used, it changes the sign with the signs that are there. So that's why I'm saying you have to use a negative. A positive does not affect anything because anything that you affect by a positive, it remains as it is. Remember that. So meaning to say you are supposed to use a negative to factor out. Then after that, you have the common brackets, write them in the way that you understand those same brackets that you have. Got this bracket, minus 3. So if you consider, I've got 2 minus 3 and minus 3 plus 2. These are the same, but 2 minus 3 and 3 minus 2, these ones, they are not the same. 2 is positive, here it's negative. So they are no longer the same. But here 2 is positive, 2 is positive. The order is not the same, but the numbers, they are having the same signs. That is what we are now having on this case to say here, the same term that I'm having here are the same and having the same sign. It's a positive, it's a positive. B, the part of B, it's a negative, it's a negative. But in the first place, it was different. It's positive A. Here, it's minus A. They are not the same. They are not the same. So I have to consider factoring out a negative to be the same as this and also this to be the same as this. Then I can factor out the highest common factor, which is the common bracket at the end. So you just have to work with more questions.